Hi everyone, we are from Nam Hua High School and will be presenting our solution to part 2 of the secondary math challenge problem. The problem is to come up with the optimal strategy to spray the pesticide so that total weight after 180 days can be maximized. What is optimal strategy? It is the total weight of plants and number of plants being the highest, as well as minimum number of pesticide is used. During our approach, we consider using differentiation and exponential function. As the graph will fluctuate a lot as methods become more complicated, given our current knowledge and time constraint, we are unable to use these two methods to solve the problem.
Hi everyone, I'm Wen Tao, and I will be continue introducing the problem. For our assumptions, we have 4 assumptions. First of all, we use the mid-class value, and the next assumption is the sequence of events. We assume that worms will grow first, and then we spray the pesticide, then after that worms will eat the plant. So in this case, we create a specific scenario so that we can make our calculations easier. And our next assumption is when the plant dies, the worms will relocate to another plant. So in this case, the total number of worms will not be affected, and we can simplify our calculations. And the next assumption is, given the probability that 2% of plants will die after one spray, we calculate that for every 44 sprays, one plant will die. So in this assumption, we can calculate the number of plants left after 180 days. So for our solution, method A, we consider the extreme case whereby we do not spray pesticide at all. And we calculate using the formula of the finite geometric series, and we find out that there will be no plant left because the amount of plant eaten is 1.1 times 10 to the power of 11 gram, which is very large. So in this case, it is impossible to do not spray pesticide at all.
I'm Qinghe. Now I'll be introducing to you method 1. For the method 1, we'll be spraying the pesticides every 2 days. Using trial and error, we realize that for the first 14 days, the number of worms on each plant is more than 2. However, after the 14 days, the number of worms on each plant will be less than or equals to 2. Therefore, we can safely assume that the number of worms on each plant for the remaining 166 days will always be 2. As given in the question, there are 2 plants that are genetically immune to the pesticide. However, I would like to point out that we made a mistake here in the report whereby we multiplied by 30% instead of 70%, as you read the question wrongly. Moving on, we'll first calculate the amount of plant eaten by the worms after the course of 180 days. Firstly, we will calculate the amount eaten for the first 14 days, and we will take 0.055, which is the amount of plant eaten by each worm on each day, multiplied by 1,000, which is the number of plants, and multiplied by 56.8, which is like the total number of worms in the course of the 14 days. After that, we will plus 2,000, which is the total number of worms on each day, multiplied by 0.055. Therefore, we will get 21384. Next, we will find the weight of plants, assuming that they are not eaten by the worms, and we will get a result of 207,584. I would like to point out that for this equation, we use 998 instead of 1,000 because there will be 2 plants that will die at the end of the 180 days. As for every 44 spray of pesticide, there will be 1 plant dying. Lastly, taking the weight of plant without being eaten, minusing the amount eaten by the worms after 180 days, the total number of weight left after the 180 days will be 186,200 grams.
Hi, I'm Luis and I'll be explaining methods 2 and 3. Method 2 is to spray daily. And using the same method as method 1, we found that it is after 4 days where the number of carbons per plant is less than 2. Hence, in our calculation, we use 176 instead of 180 as we minus away the 4 plants. After that, we will add back. To calculate the number of the weight of plant without being eaten after 180 days, we will use 996 instead of 1000, and in the course of 180 days, 4 plants will die. Therefore, the total weight of plants left after 180 days is 186933 grams. For method 3, which is to spray twice a day, we found out it only requires 1 day for the cutworms to be less than 2 per plant. And in our calculation, we will calculate the weight of plant eaten in 179 days, adding the 1 day where the number is more than 2, which is 3.50 cutworm per plant. And we found out that 8 plants will die in the course of 180 days, and hence we use 992 plants in our calculation. And after subtracting, we found that the weight of plant left is 186453 grams. So in conclusion, after comparing the various weight of plant left after 180 days, we found out that method 2, which is to spray daily, is our optimal strategy.